Hey there, welcome back to another video. Thank you for joining me. We're talking polynomials today, and specifically we're in the playlist about factoring polynomials. So in this video, I want to answer the question, why do we factor polynomials? I think a lot of the difficulty in the factoring subject in this area comes from the fact that when we first encounter this subject, we don't really know why we're doing this. And so I would like in this video to just answer that question. And in order to do that, we're going to look initially at a very simple equation. Let's look at the equation 3 times x equals 0. So when we look at this equation, what we have here is we have a product of two numbers that equals 0. Now, the only way to get a product to equal 0 is if one of the terms in the product is equal to 0, one or more. So in this case, we have either 3 equals 0 or x equals 0. Now, since we know that 3 does not equal 0, we find that to satisfy this equation, we have to take x equals 0. And this is pretty clear because, again, it's just a very simple product. But this is a very, very powerful tool. If we can put a polynomial in the form of a product, then it's much easier for us to solve it, okay, when we equate it to 0. For instance, let's look at this equation, x minus 2 in parentheses times x plus 1 equals 0. Again, we have a product of two terms that equals 0, right? This is our first term, call it A, and this is our second term, B. And so we have A times B equals 0. Okay, for this to be true, for A times B to equal 0, we have to have either A equals 0 or B equals 0, right? One of these terms has to be 0 in order to have the product equal 0. So what do we get here? So if A equals 0, that means that x minus 2 equals 0. Now this is an equation that we know how to solve. This is pretty easy. Let's just add 2 to both sides of the equation and we get x equals 2. So that's one solution. So if we take x equals 2, A equals 0, and then A times B equals 0, and we're good. What if B equals 0? That would mean x plus 1 equals 0, right? We're here. If x plus 1 equals 0, let's subtract 1 from both sides, and we get x equals negative 1. Okay, so that's our second solution. So this, when x equals negative 1, and if we insert it in B, so B equals negative 1 plus 1, that's 0, and then A times B equals 0. Okay, so this was not difficult. To solve an equation that is already factored into these simple linear terms is not so difficult because one of the terms has to be equal to 0. And we check all the terms, and that way we find all the possible solutions. But now, what if we were, instead of solving it this way, what if we would take this equation, x minus 2 times x plus 1 equals 0, and instead of solving it this way, let's open the parentheses and turn it into a full polynomial. How do we do that? Well, we use the distributive property. Let's write that in red just to emphasize. So you've learned the distributive property over and over, or the distributive law, but here it's where it really shines, and it's really important to use it correctly. So when we're multiplying things inside parentheses, we have to make sure we multiply every term in one parentheses by every term in the other. And let's do that real slow here. So let's take this first term. Let's take x here times the term there. X times x, that'll be x squared, right? Now in blue, let's do x times the second term. That's x times 1, that's just 1x, right? So that's x. I'm just going to write it as x times 1 so it's clear. Let's take green now for the third term. So now we multiplied x by both terms. Now it's the 2's term. Okay, now note that our 2 has a negative sign. So it's minus 2 times x, right? That is our third term. And finally, our fourth term comes from multiplying the negative 2 by the 1. So we have again negative 2 times 1. And all that is equal to 0. Okay, now let's gather up our like terms. So we have x squared here. We have x times 1 minus 2 times x. So we have 1x and then we take away 2 x's. So that's just negative x. So it's minus x. And then this term is negative 2 times 1. So we have minus 2 equals 0. Okay, so this is our polynomial. And if we were given this polynomial and asked to solve it, it might be a little bit difficult without the factorizations. But with the factoring now, if we know how to take this and factor it as we did initially into this equation, then our work is easy from here on, right? Then we know that x equals 2 and x equals negative 1 are both our solutions, right? So this is the power of factoring, and this is why we factor. But what enters here strongly is the distributive law. So we have to make sure we're counting our terms correctly. But once we factor our polynomial that is within an equation, solving it becomes much, much easier. So in the next few videos, we'll look at how we factor different equations and polynomials, and we'll try to go over all the tricks and tips for easy factoring. So thanks for joining me, and I hope you check out the other videos on factoring of polynomial equations.